Good afternoon. I do want to apologize for not being with you today. I'm out of the classroom to try and work on curriculum for you, videos that will help you, and so on. We are going to walk through a couple of examples at this time. You should have a packet in front of you titled Using Parallel Lines. Go ahead and write your name, date, and period at the top. We'll be touching on a couple of examples on each page, so you'll follow along with me, and then you'll have the remaining time in the period to work. Here we go. I'm on the front page. I'm in section 2. You should see a diagram that looks like this, along with corresponding questions 10 through 18. Starting off with number 10. Label with me, please. The measure of angle 4, 45 degrees. And there's something else that we need to be aware of in order to be able to work through any of these. Okay? We need to be aware of the fact that we're given A parallel to B and C parallel to D. Always glance around the diagram to see if there's additional information. Knowing that we have two sets of parallel allows us to see those congruent relationships and supplementary relationships that I was talking about in the video last night. Okay? Here we go. If we're given the measure of angle 4 is 45 degrees, they're asking us to determine the measure of angle 10. Here is one way of many ways that you could do that. To go from 4 to 10, there is no direct angle relationship. But we've been talking about corresponding angles. So there is a connection between angle 4 and angle 9. Last night in our list of congruent pairs and supplementary pairs, corresponding angles were congruent. If angle 4 is 45 degrees, so is angle 9. At this point, our next relationship gets us from angle 9 to angle 10. Angles 9 and 10 are a linear pair, and we know from unit 1.2 that linear pairs are supplementary. If angle 9 is 45, subtract that from 180, angle 10 is 135. Is that the only way to work through that problem, the only path that you could take? Absolutely not. Okay, there are lots of other ways. Next, number 11. Please find angle 16, label it 72 degrees. How are we going to go from angle 16 to angle 3? So somehow we need to get from here, what we know, up to angle 3, our question mark. Let's talk about one way to get there. From angle 16, we know that 8 is a corresponding angle. When parallel lines are given, we know that 72 degrees for 16, copies and pastes, corresponding angles are congruent. Next, from angle 8, let's figure out another relationship. Okay, we could talk about 8 to angle 6. Again, corresponding angle pair. When parallel lines are given, corresponding angles are congruent. Last but not least, 6 gets us to 3. 3 and 6 form a linear pair. Take that 72, subtract it from 180, and we are left with 108. Again, is that the only path that you could take to get to angle 3? No. Okay, and I do challenge you to figure out what other paths there might be. I will tell you, we took 3 jumps. There is a path for this one that requires only 2. Okay. Next up, number 12. If we're given that the measure of angle 3 is 88 degrees, how do we go from angle 3 to angle 13? Well, 3 and 13, take a look at that relationship there. I think we can make this one in one jump, because 3 and 13 are a very specific angle pair. I hope, and I know many of you are thinking, alternate exterior. When parallel lines are given, alternate exterior angles are congruent. Last one on the front. Take a look at 17. 17 gives you a sum, but notice it's not 180. They're telling us that the sum of two particular angles is 144. Let's go check out those two angles, 7 and 15. Based on the positions of 7 and 15, your transversal is B, your parallel lines C and D. The position of those angles indicate that they are corresponding, and when we have parallel lines, corresponding angles are congruent. So that 144 can be split evenly between those two angles. Each angle measures 72 degrees. Now that we've figured out each one of those, they're asking us to tackle angle 13. So figure out where 13 is in comparison to 7 and 15, and we'll see that 13 and 15 sit together on the same transversal D. What type of angle pair relationship do they share? Both 13 and 15 are corresponding angles. On parallel lines, corresponding angles are congruent. Understanding your angle pair relationships is pretty important here. Okay? If you have any questions about 10, 11, 12, or 17, jot them down in the margin. Ms. Banning wants to hear them on Friday. Next page. Go ahead and flip to the back side of page 1. Please find question number 22 at the top. I want everybody to add something very, very important to the top of this page. Given A parallel to B. That information is critical for us to do any of the problems on this page. We're going to work on 22 and 24 together. Drop down to 28 at the bottom. Here we go with 22. We're given two angles, 3 and 5. Head over to your diagram, label them with me. 23x plus 15, 34x minus 29. Think about your angle pair. We know that we have parallel lines, so we may have a congruent relationship, we may have a supplementary relationship. It depends on the angle pair. Here we have two angles inside the parallel lines, different sides or alternating sides of the transversal. We've got some AIA going on. That should be in your congruent list. Equal sign goes between them. Equation, 34x minus 29 is equal to 23x plus 15. Take a few seconds, solve for x. Move the 23 to the left. Let's move that constant 29 to the right. Easy division here. X value of 4. We're not done. Take that 4 back to angle 5. 34x minus 29. Let's substitute. And practice doing these without a calculator. You will not have a calculator on the Unit 1.3 test. 34 times 4, that's 120, plus another 16, 136. Take away the 29, and we are left with 107. If angle 5 is 107 degrees, you are correct in thinking that your picture is not drawn to scale. That's okay. But now we need to find angle 2. Well, if this is 107, think about what angle 1 would be. You've got a set of corresponding angles. 107 up here as well. Angles 1 and 2 are linear. Subtract that from 180, and we're left with 73 degrees, the measure of angle 2. Next up, 24. I picked this one specifically for you guys because it's another quadratic. I noticed from grading the test that we do need some more practice with those quadratics. For 24, clean your slate. We've got some new expressions, different angles. Let's label the angles 1 and 3 that were given. X squared plus 7x, 2x plus 36. Think about the type of angle pair that you've just identified. vertical angles. One thing we know to be true about vertical angles, they are always congruent. Okay, so that tells us how to write our equation. X squared plus 7x is equal to 2x plus 36. Because it is quadratic, we're going to push all terms to one side, and this time we want to push to the left so that the x squared term is positive. Moving 2x and 36 to the left, x squared plus 5x minus 36 is now equal to 0. At this point, you need to consider your factors. You want a product of negative 36. You also want a sum of positive 5. Think of two numbers that multiply to negative 36. Those same two numbers adding to positive 5. I'll give you a few seconds. The goal being you write them down before I write them down. You're looking for x plus 9 and x minus 4. Solve each one of those parentheses for 0, and we end up with an x solution here of negative 9, an x solution here of positive 4. Before we decide to just cancel out a solution, we need to figure out if they're reasonable. Take each x value, substitute it back into your expressions. So take that negative 9, quantity squared, plus 7 times negative 9. You've got a positive 81, you've got a negative 63. Guess what? That angle measures a positive 18 degrees. We can't throw that negative 9 away. Take the positive 4. Same thing. Square it, add the 28 there, and we're going to end up with 44 degrees. Both solutions produce positive angle measures. We're going to go ahead and accept both x values and both 18 and 44 degrees. We've got two measures for angle 1, which tells us we're going to have two measures for angle 8. Let's look at the relationship between 1 and 8. We do have parallel lines, so ask yourself what kind of angle pair here. How about same side exterior, SSEA? If they are same side exterior, I hope you're thinking the same thing I am. They are supplementary. What is the supplement of 18? 162. And what is the supplement of 44? 136. We will accept all of the answers that we found for 24. Last one on this page, number 28. As I'm shifting my paper and erasing the board, I want you to go ahead and label the information that's given in number 28 on your paper.
Genesis Harlow, if you're in the building, can you please report to the front office?
Number 28. How many of you labeled angle 1 and labeled angle 2, but forgot to label that A and B are parallel in your diagram? If you forgot those arrows, please go back and add them at this time. Let's find some missing angle measures. And we're going to focus on one vertex at a time. The vertex with 10, 11, and 12. You guys understand vertical angles and linear pairs very well. Let's go ahead and fill in the missing 12, 120. We know that 10 and 11 form linear pairs with the angles that are given, 60 and 60 to get us to that total of 180. Okay. Moving to the top vertex. You're given angle 2. 2 is vertical to 5. No work needed there. Next, in order to figure out the remaining 4, we're probably going to need to get some information from that bottom vertex. For example, I noticed that 4 and 11 are corresponding. When you have parallel lines given, corresponding angles are congruent. Bring that 60 up. We know 7 is vertical, copy paste. And then to figure out 3 and 6, consider your straight angle measure, 180. You've already got 140 degrees. Figure out that missing chunk to get to 180. You're missing 40. Copy paste to 6, you got vertical going on. Last vertex, 8 and 9. Now you got to think for a minute here, because are you going to use the top vertex to help you or the left vertex to help you? Figure out where your parallel lines are. Parallel lines running horizontal here, so we have to focus on a transversal that will connect the two vertices on the parallel. Looks like we're using that top vertex. Okay. Now, angle 8. How does that match up or correspond, or is it alternate interior to something at that top vertex? We could say that 8 is corresponding to 3, or that 8 is alternate interior to 6. Go ahead and bring that 40 down to 8. 8 and 9 are vertical, so 9 is also 40. Go ahead and take a moment. Make sure that you've filled in all of our known angle measures at this time. Go ahead and flip to the next side. I'm looking at the front side of the second paper. I see questions. I see questions 29 through 32. Underneath that brilliant, awesome, amazing, try it, puzzle of 32, you have all the answers for 1 through 32. Okay? So any additional problems that we did not touch on in this video are now your practice, and you can check your answers, okay, as needed. Go ahead and flip to the back side of the second paper. You should see the title, Proving Parallel Lines and Angles. Go ahead and make that flip. In order to help us, I encourage you to take out that salmon sheet of paper, the list. We're going to need that. Now that you've taken out the list, there are 3 columns. I want you to look in the very right column, the third column. Are you seeing CA, AIA, AEA, and all of our new angle pairs now in the reasons in that third column? We're going to be using some of those today. Let's take a look at how we can apply them. They're giving us a statement, angle 1 congruent to angle 8. Head over to your diagram, find that in the picture. Angle 1 and angle 8 are alternate exterior angles. Now, were we given that line A is parallel to line B? Go back and look. Given A parallel to B, we have to see that. Okay? When you have parallel lines, those angles are congruent. So we pulled this reason from the list. If lines parallel, then AEA congruent. Let's try a couple together. Angle 4 and angle 5. 4 and 5 in your diagram inside the parallel lines, alternating sides of the transversal. So we're looking at AIA. Go to your list, right column. Do we see anything about AIA in that column? I'm hoping your eyes landed on if lines parallel, or if parallel lines, then AIA congruent. Number 3, angle 4 and angle 6 together are 180, supplementary. Think about the angle pair there. Inside the parallel lines, same side of the transversal, we're looking at SSIA. Go to your list, right column. Do we see anything about SSIA? If parallel lines, then SSIA congruent. Last one together, number 4. Measure of angle 1 plus measure of angle 2 equals 180. Find your angle 1 and angle 2 in the diagram. Think about what type of angle pair you have there. From last unit, we know these to be linear pairs, but that may not be in the right column. Check your list. See what we see about angle or linear pairs there. Anyone finding one that works? If LP, then sum angles is 180. That's going to be your best fit property there. All right, drop down to the bottom of this side. Please find numbers 9, 10, and 11. Up to this point, we'd been given parallel. But what if you were faced with an example or a problem where they gave you some kind of congruent or supplementary statement and asked you to determine which lines were parallel in that picture? That is something you're going to need to be able to do. Let's do a couple together. Number 9. If angle 3 is congruent to angle 6, go to your picture. Okay, take a look at angle 3, take a look at angle 6. Think about what type of angle pair they create. AIA, alternate interior angles. If we know that those angles are congruent, there is a set of parallel lines. Now, would those lines be A and B, running parallel? Or does this angle relationship show that J and K are parallel? Answer here, J must be parallel to K. Number 10. This time we're given that angle 7 is congruent to angle 14. Go to your picture. Please find 7. Please find 14. Think about what type of angle pair you're looking at. Okay. Alternate exterior. So which lines must be running parallel to make these alternate exterior? A parallel to B. Last one, number 11. If angle 3 and angle 12 are supplementary, notice the difference in my markings this time. Different arches, 1 arch and 2 arch, they are not congruent. If they're supplementary, which pair of lines must be parallel? Think about your angle pair. Definitely same side of the transversal, but exterior to what would be the parallel lines. I think we can see that A must be parallel to B to make this statement true. All right, take a breath. I want you to flip over to the front side of the very last paper. Find questions 18 and 21. In 18, there are 2 variables, x and y. This does not automatically mean that you will have a system. Okay, let's see what happens. I think it's a little bit easier than we're thinking. You have 2 sets of parallel denoted by the 2 sets of angles, or excuse me, arrows. We're given the 140, okay, and then jumping over both parallel lines to the y. What angle pair are you thinking here? Are you thinking same side exterior? I hope so. On parallel lines, same side exterior. Supplementary. What's going to get us to that total of 180? 40 degrees. Now that we know that 40, let's glance down at our x expression. What relationship do this 40 and this 2x plus 10 share? They are corresponding angles, and on parallel lines, corresponding angles are congruent. Small equation. Go ahead and solve for x. You guys are going to be pros not only at algebra but at geometry as well by the end of this year. We find that x is 15. Okay, no system. Not as bad as we thought, right? 21. Difference here. This time we have an x, a y, and a z. Oof. Let's see what we've got going on for this one. If we're given the 40, we're given the 90. All right. Well, let's see here. If that's 90, then its supplement is also 90. And back in middle school, we talked a little bit about triangles. You guys know triangle sum. The 3 angles in a triangle must add up to 180 degrees. degrees. If you know 90 and you know 40, can you determine that x value? Yes, we can. We've got 130. What's that remaining jump to get to 180? We're looking at 50 degrees. If x is 50, let's slide up the transversal. If this is 50, corresponding angle must also be 50. 5y equals 50, y is 10. Last one to find, z. I'm looking along this straight line, and I see that 50 degrees plus something must get me to the straight angle of 180. 2z has to give me that remaining 130, and if 2z is 130, that leaves z to be 65. Last problem for us together. Please go to the back page, number 25. Number 25, go ahead and label your picture for angles 3, 6, and 7. Notice that each angle contains both an x and a y. I picked this problem for a particular reason. We need to practice systems. Okay, some of us are doing well with systems on the test, some of us need a little bit of help. So let's go through another example together. To make this a systems problem, let's take a look at some of the angle relationships that we have. Angle 3 and angle 7, think about what type of angle pair they are. Okay, corresponding angles, what do we know to be true about corresponding angles when parallel lines are in the picture? They are equal to each other. First equation, 3x plus y is equal to 4x minus 2y plus 5. Next relationship we need to see. Take a look at 6 and 7. 6 and 7 in our picture are a linear pair. They are supplementary. So we need to add these two angles together, set them equal to 180. 6x minus y plus 4x minus 2y plus 5 has to equal 180. Now I won't lie, those look pretty nasty, but let's see if we can simplify anything to make it easier. When we do systems, generally your x and y terms are on the left, any constant terms on the right. So go ahead and move your 4x, move your 2y, and we end up with negative x plus 3y is equal to 5. That looks a lot more manageable. Over here, multiple x terms on the same side, multiple y terms on the same side. Do some simplifying. 10x minus 3y, move the 5 to the right, equals 175. All right, now this one's not looking so bad. Let's go ahead and write them vertically. And think about what method might be best here. Should we use graphing? Should we use substitution? Or should we use elimination? Which one are we set up for? Okay, if you're looking at that y term, we've got a plus 3 and a minus 3y. I think elimination would work out very well. Go ahead and eliminate y. 9x equal to 180. Divide by the 9 both sides, and now x is 20. Using x to find y, does it matter which equation you substitute back into? The answer is no. Pick one, and let's get to work. I'm going to say negative 20 plus 3y is equal to 5. Move the 20 to the right, 3y equals 25, and divide. I'm going to leave it as a fraction, but we're also going to consider the decimal. 8.3 repeating. Last thing we need to consider, they asked us to find two angles, angle 3 and then angle 8. Let's focus on angle 3 because we have an expression to represent that right now. 3x plus y, fill in your values. 3 times the 20 plus 8.3 repeating. 60 plus the 8.3 more, we're looking at 68.3 degrees repeating. How does the measure of angle 3 compare to the measure of angle 8? Well, there's no angle pair name to describe those in one jump, but if we know 3, do we also know the measure of angle 7? Corresponding angles congruent, so that would make this 68.3 degrees as well. I see a linear pair happening. Subtract that 68.3 degrees from 180, and we're left with 111.6 repeating. Measure of angle 8, 111.6 degrees repeating. I'm going to make sure my answers are accurate. If you have any questions on any of the remaining problems, please write them down so that your teacher can answer them in class with you. Okay? Good luck working on the remainder of the packet.